This one? Very good. Awesome. Good pick. 83 it is. So 83 on page 1220. Makes me laugh. Okay, so 25 divided by 5 the square root of 2 minus 3 the square root of 5. Then I recommend we choose one with x too in there. X and y, whatever. Okay, so we're trying to rationalize the denominator. There's nothing we can do to simplify. Because normally I would say, well, if we can simplify, we'll simplify it. But in this case, we can't. So we're ready to multiply top and bottom. Remember, this must equal 1. And it will. So what will you multiply top and bottom by? Yes. 5 the square root of 2. Very good. 3 the square root of 5. 5 the square root of 2 plus 3 the square root of 5. Is that clear? Why? Yes? Good. The numerator is the numerator, and there is nothing I can do about it. So 5 the square root of 2 plus 3 the square root of 5. But now please carefully square the first term and give me the answer, and square the second term and give me the answer.
When you square 5 radical 2, it's like 5 squared times parentheses square of radical 2, right?
Right. So I have to square this term, and I get 25. And when I square this piece, this factor and this factor, so this is 25 and this is 2. So 25 times 2 will be 50. Very good. And now I square this. I square this. 5. 9 times 5. Excellent. Now I perform the operation. Don't try to simplify in a sum. Careful. So this is 25 parentheses 5 the square root of 2 plus 3 the square root of 5. And this is 50 minus 45, which is 5. And now you can simplify, because you're simplifying factors. You do not need to distribute. This is good enough. Very good pick. Now, I like to get to pick myself a one with x and y and variables, in other words. Any questions on 83, please? Any questions? Okay? Perfect. So let's look at, let's say, 92. Same page. 3 the square root of x plus the square root of y. Everything over the square root of y minus 3 the square root of x. So we're looking at rationalizing denominators of radical expressions. And this is 16.5. And after we do more examples, we can look at the very last one, radical equations. Okay, so I see that I cannot simplify top and bottom by anything, but I'm trying to rationalize it. And let's see what we get. First of all, what do I rationalize it with? And the answer should always be 1. 1. Always remember, because if you multiply the top without multiplying the denominator, you're changing the whole thing. It's not the same. But if you keep in mind that you're rationalizing by 1, but specific type of 1, right? It has to have the same quantity top and bottom, but it's a specific quantity, not just any quantity, right? So what will you choose? The square root of y plus 3 the square root of x. Awesome. Indeed. Now the numerator, and I don't have enough room here, so I'm not going to continue here. The numerator needs work as well. 3 the square root of x times the square root of y. I have to distribute. 3 the square root of x times the square root of y. How much is the square root of x times the square root of y? The square root of xy. Excellent. 3 the square root of xy plus 3 times 3 times the square root of x times the square root of x. Again, we assume everything positive. 9. So 3 times 3, the square root of x times the square root of x. Very good. Awesome. Well done. Okay, the square root of y times the square root of y now. Very good. Finally, the square root of y, I should say 1 times 3 times the square root of y times the square root of x. 3 the square root of xy. Perfect. And now the denominator. The denominator is easy because I'm using a formula. The first term squared. Very good. Minus the second term squared. I have to square both pieces. Minus. Yes. And squared. I cannot just square one piece. I have to square, yes. Remember, we have to square both pieces. If you simplify this with this, that will be a terrible mistake. We cannot do that. But we can combine like terms at the top, and look, these are like radicals. So the answer will be 9x plus y, but plus. Very good. The xy, y minus 9x. That's it. Any questions? Any questions before we start the last topic? Any questions? Now let's look at a few examples here and see if we need to work on anything else. Multiplications, maybe some multiplications of radicals. We just did a few, but let's see if you would like to look at anything else before we look at equations. We've been doing this basically with rationalizing. Rationalizing is beyond this step. But see if you want to work on any other. We just did a few. You want to multiply any of these?
How about 26?
26 is a good one. Excellent. Good pick. Let's do 26. Perfect. So 26 on whatever. So the square root of 2x minus the square root of y squared. This is to refresh our memory on something that we covered in our agreement, and we know how many terms we have to obtain. How many terms will we have to get? We have a binomial squared. It's not a binomial, but we have 2 terms squared. How many terms? How many terms when we square a binomial? Yes. Thank you. Indeed, 3 terms. Can anyone give us the first term squared? Very good. Minus 2 from the formula in front. The square root of 2x times the square root of y. 2 the square root of also 2. Have to multiply them. 2xy. The square root of 2x times the square root of y is the square root of 2xy. And then plus the last term squared, please. Y, very good. No one can simplify this. This is it. Okay, do you think we need anything else? Division, multiplication, anything? Is it a yes or a no? Yes? No? Or we can move on to radical equations. which is the last topic before the test. Radical equations? Okay, perfect. These are not very friendly.
You said now, right, buddy?
They are not very friendly. Not very friendly. Radical equations. Okay, we're going to start with a very simple one. And even before that, let's suppose I have x equals 2. And you should ask, what does this have to do with anything? This is not a radical equation. There is no radical in it. What are you trying to do? I'm trying to make a point. Let's suppose I have this equation and I decide to square both sides. And you should ask why. And I'll say I'll never do it, but I'm trying to make a point. So initially I started with x equals 2, and then I squared both sides, and I got the equation x squared equals 4. How many solutions does the original equation have? I know it's a silly question. 1. How many does the resulting equation, after I squared both sides, I got this equation? How many solutions does this one have? 2. So I started with an equation with one solution, and I ended up by squaring both sides or raising both sides to a power. I got this equation that has 2 solutions. Obviously, one of them does not belong there. We know how to solve this. We've done that last time. X squared minus 4 equals 0, x plus 2. We factor x minus 2, and we get x equals 2 and x equals negative 2. But I started with x plus 2. This is okay, but this is not okay. The point I'm making is that this principle of raising both sides to a power may result in solutions that do not work in the original problem. We call them extraneous solutions. This is an extraneous solution. Doesn't work here. If I replace x by negative 2 does not equal 2. So we have to be careful with this system. Okay? Careful with this system or this procedure of raising both sides to a certain power. We have to check solutions back to the original problem. So this is what I was saying at the beginning. In this particular situation, we must check solutions. This is part of the problem. So note, when raising both sides to a power of an equation, of course, to a power, must check solutions in the original problem. It's part of the solution. We must go back and check. So, and now, when do we apply this method? Not on x equals 2, of course, but let's say on the cube root of x plus 1 equals 2. This is a radical equation. What do you think we need to raise both sides to? Which power in order to eliminate the radical? What power is radical? The cube root. What did we notice? What did we talk about? The cube root is what power? If this is the cube root of x, is x to what power? It has to be a fraction. One more time. So we can't say that the radical, the cube root, is power 3, because the exponent has to be a fraction. So x to the third is not the same with x to 1/3. It's a totally different story, right? So then the cube root of x has x to which power? It's 1 over 3, right? 1 over 3. So then what do you think we're going to have to multiply, raise both sides to eliminate that power 1/3? Which power do we raise both sides to eliminate power 1/3?
Who's gotta raise it to like?
It has to be 3, of course. Oh, I didn't hear. I'm so sorry. My apologies. I didn't hear. I have the fan right here on top of me, and you have to speak up. My apologies. Yes, indeed. We have to raise both sides to the 3rd power. So then the left-hand side will be x plus 1. The right-hand side will be 8. So therefore, x equals 7. But it comes with a question mark. Because we raise both sides to a power, we don't know if this works in the original problem. Well, I have to be honest. Every time we raise to an odd power, it will always work. But if we raise to an even power, it's not guaranteed. But let's follow the rule. I go back to the original problem. I replace x by 7. 7 plus 1 I have to add first. 8. The cube root of 8 is 2. Yes. So then I'll say x equals 7 is indeed the solution. Any questions? Okay, perfect. Let's look at a few examples. Where is my... right here, radical equations. Radical equations. Okay, so let's start with, and then we will look at word problems. So let's start with a nice one, like 2, on page 1229. So the square root of 5x minus 1 equals 8. Okay, so this is a square root. On the left-hand side, it's a radical equation. What should we do to both sides to eliminate the radical? Yes, excellent. How come that I don't cube? I want to cube. Will that work? Will it? No, it will not work because the power is 1/2.
Right, you get a fraction.
Exactly, the fraction is 1/2. If I raise it to the 3rd power, it will not do any good. Very good. The left-hand side is
5x minus 1.
awesome, and the right-hand side is 64. So then I have 5x equals 65. So then x equals 13. But I have no idea, especially when I square or take to the 4th power. I don't know if this is going to work or not. So I have to go back to the original problem and see if the answer is positive 8. So 5 times 13 is 65. 65 minus 1 is 64. The square root of 64 is 8. So therefore, I will say, yes, it works. It is the correct answer. That's how we solve radical equations. Okay, so please choose now anything you like. Some of them are more difficult, of course. These are more difficult. These are less difficult. Okay, I'm ready for any problem you pick. We want to look at 17? Good. That's a very easy one, though. That's okay. Let's do it, and then we'll pick another. I'll let you pick. Okay, so it's a good problem. So 17, 1, 2, 2, 9. Okay. We have the cube root of 2x plus 11 equals 3. You can choose the next. Okay, so we need to raise both sides to a power to eliminate the radical. Which power would that be? 3. Very good. Awesome. Because the power for the radical is 1/3. So let's do just that. 3rd power. So 2x plus 11 equals 27. And then 2x equals 16, and x equals 8 with a big question mark. I have no idea if this works or not. Go back to the original problem, which is the cube root of 2 times 8 plus 11, and see whether this is 3. So 2 times 8 is 16. 16 plus 11 is 27. 27, the cube of 27 is 3. So then I would say yes, indeed, x equals 8 is the solution. And no one can find another. Which one did you pick? 19. 19 it is. So let's look at 19. Okay? You're missing all the difficult ones. I'll choose the next one. So the cube root of 2x minus 6 minus 4 equals 0. However, it's a very good one because of the following point. Radical, if the equation has one radical, the radical has to be isolated on one side. It's a must, otherwise you can't square. Because if you square the left-hand side, you'll never finish. You'll get 3 terms, and then 3 terms, and then 3 terms. You will never end. You will never end. Correct. So we have this. And now we can cube both sides, because we have to. So therefore, we have 2x minus 6 equals 64. It's linear. 2x equals 70. So x equals 35. And we are not guaranteed. I have no idea whether it works or not. I have to go back to the original problem. 2 times 35 is 70. 70 minus 6 is 64. The square root of 64 is 4, and 4 minus 4 is 0. And I will say definitely yes. Okay, allow me to choose the next, like 12. X equals the square root of 3x plus 7 minus 3. This is not a trivial equation by any means. Okay, what do you think the first step would be? Yes, yes, of course. So the left-hand side will be x plus 3, and the right-hand side will be the square root of 3x plus 7. Only now the equation is ready for what? Yes, what if I want to cube? Will cube work? No, because it's the square root. Okay, perfect. Now let's start with the right-hand side because that's the easy one, right? What is the right-hand side? But now you have to be very careful on the left-hand side because it's a binomial squared, which means you will give me how many terms? Excellent. So the first term squared plus 2 times 3 times x. 2 times 3 is times x. Very good. Plus the second term squared. Very good. So now this is a quadratic equation. We have to do what in order to solve it? Move everything to one side, set it equal to 0, combine like terms. Very good. X squared plus 3x plus 2 equals 0. So I subtracted 3x from both sides, and I subtracted 7 from both sides. I'm hoping that we can quickly factor this, and let's see what we get. So the options are I have no idea. I don't know. I square both sides. Anything can happen. Both may work. None. It's a second option. None may work. Or just one. I have no idea. I have to go back to the original problem, which is this. Not that, not this, nothing. Just this. No other step is considered the original problem. And I will replace x by -2. Okay. 3 times -2 is -6 plus 1 is -6 plus 7 is 1. The square root of this is 1. Is 1 minus 3 -2? I will say yes. Very good. Now I have to check -1. 3 times -1 is -3, plus 7 is 4. The square root of 4 is 2. Is 2 minus 3 -1? Yes. Okay, it happens that both work. This equation, this radical equation, has 2 solutions. Any questions?
Are there any domain issues with X?
Very good. Excellent question. Normally, this is how I learned this. I would state the domain, and I will not go back and check. Here we do something else. We don't state the domain, but we go back and check. But if you state the domain, you will know exactly whether these two fit in the domain or not. And you will not have to go back and check. It's a very good point. So what would be the domain here? I would have to write that 3x plus 7 is greater than or equal to 0, which means x greater than or equal to -7/3. So this is -2 point something, and both of them are in the domain. So therefore, they have to work. Very good point, of course. Okay, we move on to a word problem, or we continue with another example.
Did you say a word problem?
Word problem with radicals. Yes.
Let's try the word problem.
Okay, are we okay with radical equations? Yes? Yes? Should we look at another or not? It's up to you. You decide. Do you remember radical equations from the previous class? Were they presented in the previous class? I don't teach the previous class, so I don't know. Somewhat? Okay. Okay. So again, should we work on one more or move on? Move on. Okay. Okay, use the graph of the formula for, it says hang time to solve the exercises 53 and 54. Okay, so it doesn't explain, let me see, maybe it's up here. Yes, it is. It does explain. So a basketball player's hang time is the time spent in the air when shooting a basket. The formula T equals the square root of D over 2. I have to copy that. So this is problems 51 through 54 on page 1230. So we are given T equals the square root of D divided by 2. T is the hang time, and D is the time spent in the air. Right? T is the time spent in the air, and D is the vertical distance of a player's jump. D is the distance in feet. D in feet, distance up in the air, and T is the hang time in seconds. Okay, perfect. We're given the formula. Use the formula to solve exercises 51 to 52, and here we are in 53 and 54. We are given the graph of this, and they are asking us to check the answers from 51 and 52. So let's do the whole thing. So let me see if this is better. It says when Michael Wilson of the Harlem, yes, you're right, slam dunked the basketball, his hang time for the shot was approximately 1.16 seconds. What was the vertical distance of this jump rounded to the nearest tenth of a foot? So T, 1.16 seconds. We're asked to find D. Okay, so we put the information in the equation, and that's what we have. 1.16 equals the square root of d divided by 2. We're asked to solve the equation for d. This is a radical function. It has a square root in it. What do you think we should do first? I would multiply both sides by 2. I don't like squaring fractions that much. It's not a mistake. You can go ahead and square if you want to. But first I would like to clear the fractions multiplying both sides by 2. And I have 2.32 equal to the square root of d, which makes it somewhat more convenient to work with. And now, yes, now I have to square. So then d is nothing else but 2.32 squared. That's a distance up in the air. So I grab my calculator and I square 2.32 and I get 5.3824. 5.3824 feet. So now, how is your answer to exercise 51 shown on the graph? So can anyone give us the point that we just determined? The distance was 5 point, I'm not going to write the whole thing, I'm going to just say 5.4. And the time up in the air was 1.16. So let's see where we find the point on the graph. So the point is 5.4 comma 1.16. So 5.4. So roughly here. And 1.16. It says, how is your answer to exercise 51 shown on the graph? So 5.4 and 1.16. 52. If hang time for a shot of a professional basketball player is 0.85 seconds, what is the vertical distance of the jump rounded to the nearest tenth of a foot? So this time we are given, right? So we are given the time again. So the time was, this time, it was initially in the previous one, 1.16, and here is 0.85. So same question. I thought they would ask the opposite, but no, they didn't. So this time they're giving us t equals 0.85 seconds, and they want us to determine d. So 0.85 equals the square root of d divided by 2. I would recommend, like before, multiply both sides by 2 for convenience. So multiply by 2. And let's identify on the graph of the function where the new point is. So multiply by 2, 1.7 equals the square root of d. Very good. Thank you very much. And now indeed we'll square both sides, and we get d equals 1.7 squared. So the distance is, what did we get with 1.7 squared? I got 2.89. 2.89 feet. So then the point is 2.89 comma 0.85. So let's see whether we can identify the point on the graph. We should, there should be no difficulty. So 2.89 2.89 and 0.85. 2.89, 0.85. Is that clear? Okay, very good. Okay, let's choose from these problems to solve for a particular letter. We are given a formula, and we're asked to solve for the indicated letter. So we can look at 45, and we're asked to solve for L. We can look at 46, and we're asked to solve for N. Or 44, we're asked to solve for A. And 43, we're asked to solve for B. So choose any of these. So we can solve for that letter. And that is the end of the material for test 1? Any preference? 43 it is. 43, perfect. Good, 43. 1, 2, 3, 0. Okay, so we have r, lowercase r, is the square root of 3 uppercase v over pi lowercase h. And they want us to solve for v. So what should we do? First of all, we have to analyze this equation and say, oh, it's a radical. Secondly, the variable I'm solving for is under the radical. So then I have to do what? Yes, excellent. I have to square both sides, because if I don't remove the radical, I cannot reach uppercase v. Good, so the left-hand side is lowercase r squared. And what do we have on the right-hand side? V over pi h. Very good. Now I can solve for v. This is no longer a radical equation. I should either eliminate everything that touches v at once or in 2 steps. This is what I would recommend. I will multiply this side by pi h over 3, and of course this side by pi h over 3. Multiplying both sides by the multiplicative inverse of this, pi h over 3, will eliminate everything I want to eliminate. So v is alone now, and on the other side I have pi h r squared over 3. We have time for another. We have 6 minutes left, so let's use those 6 minutes efficiently. Any questions on this? Okay. So would you like to choose anything else, or would you like to go back to another radical equation? Anything? Another model to solve for a particular letter? Any preference, or I will choose? No preference, okay? I'll go back to another radical equation. So let's say 14. 3x minus the square root of 3x plus 7 equals -5. What should we do first? We're asked to solve. It's a radical equation. What will you do very first step? I realize that the radical is not isolated. Agreed? So I would like to move this here and this here because I don't like the negatives. And if I separate in this way, all terms are positive. So I move the radical that has a negative in front to the other side, and I move the -5 that has negative in front, right? The 5 with a negative to the other side. Now what? At this stage I say, oh, okay, it's separated, it's isolated. Now what do I do? And now I square indeed. The right-hand side is nice, but the left-hand side needs attention. First term squared. Excellent. Plus, multiply the 2 by the 5 first. 10 times 3x. 30x. Plus the second term squared. Very good. All we have to do now, move everything to one side and set equal to 0. So 9x squared plus 27x and plus, I think it's 18. 25 minus 7. Now let's look at this equation and say, oh, you can simplify it. Get rid of it quickly and make numbers smaller. I will divide both sides by
9.
Indeed. Always clean it up. Always make it as simple as possible. So this is x squared plus 3x plus 2 again. Isn't that funny? You picked, I picked a problem that reduces to the same thing. We just wrote that as x plus 1 and x plus 2. And the answer is -1 and -2. Who knows? Maybe. I'm not sure. This is a radical equation. I use the principle of raising both sides to a power. I don't know. It may or may not work. I copy the original problem. And I check -1. Okay. 3 times -1 is -4 plus 7. No, I'm sorry. 3 times -1 is -3 plus 7 is 4. The square root of 4 is 2. So I have -3 minus 2. Does that equal -5? Yes? Very good. So then -1 works. Now I'm going to check -2. So 3 times -2 is -6 plus 7 is 1. So this is -6 minus 1. Does this equal -5? If you say yes, I'll say yes. If you say no, I'll say not acceptable. Is this true? It's not. So I will say this is extraneous solution. Nobody cares about it. So the only solution is x equals -1. Any questions?